Hello everyone. Today I am going to discuss one more question of GATE 2023. As you can see, the question is from a differential equation, ordinary differential equation. Okay, given that there are two functions x of t and y of t, the two functions they satisfy the following system of differential equation. It means these are the solution of this system of differential equation. And the condition of x of 0, or initial condition, as you can see here, x of 0 equal to alpha and y of 0 equal to beta, where alpha and beta are two real numbers. Okay, then which of the following statements are correct? There are four options given. Okay, so first of all, we try to find the value, we are trying to find the x of t and y of t, and take the modulus of x of t and y of t. And according to the value of alpha and beta, we are trying to find the value of x of t and y of t, modulus of x of t and y of t as t tending to infinity. Is it tending to 0 or not, according to the value of alpha and beta? Okay, so first of all, we need to find the solution of the system of differential equation. Okay, so what is the system of differential equation? As you can see here, so we can write it as dx x dash t equal to y of t. We can write dx upon dt equal to y, suppose this is equation 1, and dy by dt equal to x, suppose this is equation 2. Okay, so first we need to solve this system of differential equation. So suppose we need to put the value of equation 2 in equation 1, so that we can get the one differential equation and solve the given differential equation. Okay, so you can write here, put the value of, or put equation 2 in 1. We get what we get, d square y upon dt square equal to y. Okay, suppose this equation is 3, or simple you can write dt square. Okay, so you can write it's d square and minus 1 of y equal to 0. Okay, now we write the corresponding auxiliary equation of this differential equation. So the differential equation is d square minus 1 y equal to 0. So what is the auxiliary equation corresponding to this? M square minus 1 equal to 0. So m equal to plus minus 1. Okay, so what is the solution or complementary function? The solution is y of x equal to you can write c1 e to the power e raised to power t plus c2 e raised to power minus t. Okay, suppose this is equation next, or you can write 3. Okay, now you can find the y dash. Okay, so now you can see the equation number 2, dy by dt equal to dx, or you can write dxt, or x equal to dy by dt. Okay, so I write here dx, or suppose x of t equal to dy by dt, which is equal to, what is the value of dy by dt? So differentiate this, so you can write c1 e to the power t minus, because c2 e to the power because of minus t. Okay, so we can write here minus. So this is the value of x of t. It's the value of x of t, and this is the value of y of t. Suppose this is equation 4. Okay, now the condition is what? The condition is x of 0 equal to alpha and y of 0 equal to beta. So apply this condition here. So what is the condition? X of 0 equal to alpha and y of 0 equal to beta. Okay, so from equation 4, x of 0 equal to alpha, it means you can write here by 4 alpha equal to, we write 0 in place of t, so c1 e to the power 0 plus minus c2. Okay, similarly from equation 3, so by 3, y of 0 equal to beta, it means beta equal to c1 plus c2, we write 0 in place of t. Okay, so these are two equations. Suppose equation number 5 and this is equation number 6. Now find the value of c1 and c2. Okay, how to find? If we add both equation 5 and 6, so we get c1 equal to they are cancel out, c1 equal to 2 times of c1 equal to alpha plus beta, so c1 equal to alpha plus beta by 2. This is the value of c1. Now put the value of c1 in equation 5th or 6th, so you get value of c2. So what is the value of c2? c2 equal to what? c2 equal to beta minus c1, from 6, so beta minus c1, which is equal to beta minus alpha plus beta by 2. So c2 equal to what? As you can write 2 times of beta plus minus alpha minus beta, so beta minus alpha by 2, the value of c1 and c2. This is the value of c2. So put these value of c1 and c2 in the given equation 3rd and 4th, so we get what the value of c1 alpha plus beta by 2 and c2 alpha minus beta minus alpha by 2. So put in equation this is the equation of 4. Okay, so x of t equal to what? The value of c1 alpha plus beta, so alpha plus beta by 2 e to the power t minus beta minus alpha, the value of c2 beta minus alpha by 2 e to the power minus t. Okay, similarly suppose this is equation number, you can write equation number 7. Okay, similarly the value of y of t, put the value of c1 and c2, so c1 e to the power t plus c2 e to the power minus t, the value of c1 again alpha plus beta by 2 e to the power t plus beta minus alpha by 2 e to the power minus t. Okay, similarly you can write it here plus sign, and if you want to change this plus and this minus, so you can write alpha minus beta. Okay, so suppose this is equation 8. Okay, now according to the option, first option is alpha equal to 1 and beta equal to minus 1. Okay, so if alpha equal to 1 and beta equal to minus 1, then the value of x of t equal to what? X of t equal to alpha equal to 1, beta equal to minus 1. This term is 0 and this term is alpha equal to 1, beta equal to minus 1. So minus 1 plus 1 and plus 1 2 upon 2 cancel, so it is e to the power minus t only. Okay, similarly the value of y of t when alpha equal to 1 and beta equal to minus 1, so alpha equal to 1, beta equal to minus 1, it means this term is 0 and this term is minus 2, so minus 2 to cancel out, so we get minus of e to the power minus t. Okay, now next we need to find mod of xt plus mod of yt. Okay, so mod of xt equal to what? It means e to the power minus t modulus of e to the power minus t plus negative of e to the power minus t of modulus. As you can see, if t tending to in the option first, if t tending to infinity, if t tending to infinity, if t tending to infinity, it means this goes to 0. Okay, and again this goes to 0 if t tending to infinity. Okay, because as you can see here, t is -1 and -1. So in both situation, t tending to, just a minute, I need to remove this. Okay, so what will the answer? X of t, modulus of x of t plus modulus of y of t, modulus of x of t, modulus of y of t tending to 0 as t tending to infinity. Okay, it means our first option is correct. Okay, this option A is correct. Now if you put alpha equal to 1 and beta equal to 1, then this condition is true or not? Let's check. So as you can see here, if alpha equal to 1 and beta equal to 1, so it means what? It means 2 by 2, 2 over 2 cancel out, so you get e to the power t, and here these are cancel out. Sorry, this term is 0 because alpha and beta both are 1. So we write here option B. If alpha equal to 1 and beta equal to 1, then x of t equal to what? X of t equal to e to the power e raised to power t, and this term is 0. Similarly, y of t equal to what? Y of t equal to this term is e to the power t, and this term is cancel out because alpha equal to 1 and beta equal to 1. So 1 to 1 cancel out, so this term is 0. So modulus of this equal to modulus of this, and modulus of this equal to modulus of this. So if we add both of x of t and y of t, and if t tending to infinity, then this tending to infinity, and again this tending to infinity. As you can see, if t tending to infinity, then e raised to power tending to infinity. Okay, so if t tending to infinity, then both xt, mod of xt plus mod of yt tending to infinity. Okay, so the second option is wrong because he say mod of xt plus mod of yt tending to 0. But you can see, as you can see, the mod of xt plus mod of yt tending to infinity if alpha and beta both are 1. So this option is false. Similarly, if you take the alpha value of alpha equal to 1.01 and beta equal to -1, then again this option is incorrect. And similarly, with the same method, as you can see, the option D is again incorrect. So option 1 is correct, and B and C are the incorrect option. Okay, I hope it is clear all of you, and if you have any doubt, please write in comment section. And if you like this, please like the video and subscribe my channel and share among the friends. Thank you guys, thank you so much.